You ever catch your reflection and just wonder what's really going on there? Well, in this explainer, we're going to pull back the curtain on the science of light, mirrors, and the incredible geometry that shapes the world we see every day.
I mean, think about it. The reflection you see in your bathroom mirror, totally normal. But then you stand in front of a funhouse mirror and suddenly you're all stretched out and weird. Or you glance at your car's side view mirror and everything looks tiny and miles away. It's still you, right? So what gives?
So, on the one hand, you've got the familiar, trustworthy reflection you see every morning. And on the other, you get this bizarre, distorted version of yourself. The secret here isn't about you, it's all about the shape of the mirror itself. All right, so to really understand how mirrors can literally bend reality, we've got to start with the fundamentals. And that means kicking things off with the simplest and most common type of mirror there is, the flat one. So, at its very core, what is a mirror? It's just a surface that's so incredibly smooth that when light hits it, it bounces off in a really predictable, organized way, instead of just scattering everywhere. That organized bounce is what creates the clear image you see looking back at you. Let's start with the plane mirror. That's just the fancy name for your everyday, flat mirror. This is going to be our baseline, our standard for what a true reflection really is. You know how when you look into a mirror, your reflection seems to be behind the glass? It's like your brain is tracing the light rays backwards in a straight line, creating an image where, there's nothing actually there. That's why we call it a virtual image. You can't, put a piece of paper back there and project the image onto it.
Okay, so a plane mirror gives you a pretty faithful one-to-one copy. It's the same size as you, it appears to be the same distance behind the mirror as you are in front of it, but there's one fascinating little twist to this otherwise perfect reflection.
And this is the perfect example of something called lateral inversion. It's why words get flipped horizontally, and why, if you raise your right hand, your reflection raises its left. It's also the clever reason ambulance is written in reverse on the front of the vehicle, so you can read it correctly in your rearview mirror. All right, we've established our baseline for a true reflection. Now let's get to the fun part, bending reality. The big secret to all those funhouse mirrors and car mirrors? It's all in the curve. Spherical mirrors are basically just pieces of a giant hollow sphere. Concave mirrors are the ones that curve inward, kind of like the inside of a spoon. Convex mirrors do the opposite. They bulge outward, like the back of that same spoon. And that simple little curve changes absolutely everything. A concave mirror is basically a focusing mirror. Think of it like a collector. It grabs parallel rays of light and forces them all to come together or converge at one single powerful point. A convex mirror, well, it does the exact opposite. It's a dispersing mirror. When light rays hit its surface, they spread out or diverge, and that's what gives you a much wider field of view. Now, this isn't magic, it's pure physics. And the way light behaves when it hits these curves is governed by a few surprisingly simple rules. If you know these rules, you can predict exactly what the reflection will look like in any curved mirror. So here they are, the 3 golden rules. First, any ray of light that comes in parallel to the mirror's axis will bounce through a special spot called the focal point. Second, a ray that passes through the focal point first will bounce off going parallel. And third, if a ray goes right through the center of the sphere the mirror was cut from, it just bounces straight back on itself. The cool part is, you only need 2 of these to figure out exactly where the image will form. Now, with a concave mirror, where you are standing changes everything. This is totally different from a flat mirror, where your reflection is always the same. Here, your distance from the mirror completely transforms what you see. See how this works? If you're far away, your reflection is tiny and upside down. As you get closer, it gets bigger, still upside down, but then once you get really close, it suddenly flips and becomes this huge, magnified right-side-up image. This is exactly how shaving and makeup mirrors work to give you that amazing close-up view. Convex mirrors, on the other hand, are much simpler. No matter where you stand, your reflection is always upright, always virtual, and always smaller than you are. And it's this predictability that makes them so incredibly useful. Okay, now that we've got the physics down, let's see how these awesome principles, focusing, magnifying, and widening our view, are actually put to work all around us. That amazing focusing power of concave mirrors is everywhere. We use it for a magnified view when we're shaving or putting on makeup. Dentists use them to get a detailed look at our teeth. And they're also used to create those powerful focused beams in car headlights and flashlights. And that wide-angle view you get from convex mirrors, it's a total game changer for safety. It gives drivers a much broader view of the road, and it allows security guards to monitor huge areas of a shop at just a glance. A convex mirror gives you a way wider field of view than a flat mirror of the same size could ever give you. And this is exactly why they have that warning printed on them, right? Objects in mirror are closer than they appear. You're basically trading a true sense of distance for a much bigger picture. And here it is, the secret code behind all of this, the mirror formula. It's this elegant little equation that connects an object's distance, its image's distance, and the mirror's focal length. It lets scientists and engineers predict exactly what a reflection will do with perfect accuracy. So the really big takeaway here is that a simple curve can completely change our perception of reality. A flat surface gives you the truth. A curve that caves in focuses and magnifies reality. And a curve that bulges out spreads it wide to give you the bigger picture.
It really makes you think, doesn't it? If something as simple as a curve in a piece of glass can so profoundly change our perception of reality, what other fundamental principles are out there, quietly shaping the world we experience every single day? Something to think about.